Okay, so here's another example. The diagram's the hard part too. Plane A is 6 miles from the airport's tower, so you just put A and T for tower 6 miles apart. And then you guys start for the other part here. It's 8 miles from plane B, so we're going to draw a line 8 miles from plane B. And then from plane B, plane A and the tower make an angle of 40 degrees. There's your 40 degrees. And using the tower's reference, what's the angle between the two planes? So we're going to call that our unknown angle theta. Okay? So it's an angle we don't know. So we're looking for an angle, so we're definitely going to be using the first side here. Although it doesn't give us, it doesn't give us T, A, and B, it gives us A, B, and C. So isn't it just as easy to, instead of C, we're going to call this one T and little t. Is that okay? So if that's capital T, this one's little t. If that's capital A, this one's little a. If that's capital B, this one's little b. And we want to find, definitely we're going to keep this one, because we want to know capital T, and we have little t. And what else do we have? We have capital B and we have little b. We don't know anything about A's, so we're definitely not going to use that one. So the formula we're going to pick is sine B over little b equals sine T over little t. Sine big B over little b equals sine big T over little t. And the capitals and the smalls make a difference again. And then we substitute everything we can. So sine, well, it's easy to get the formula already, or the diagram, it's easy to see. So sine 40 degrees over little b is 6. And we'll leave the units out as long as they stay the same. These are both in miles. Sine big T is, we don't know, divided by little t, which is 8. And again, we want theta on its own. So, sorry, I paused and got distracted. Where was I? So we want theta on its own. So I'm going to multiply both sides by 8 to get rid of that 8 on the bottom. So the 8's go away. So I'm going to rewrite it from this side. Sine theta equals 8 times sine 40 over 6. Okay? So the weird thing again is to get rid of that sine theta, what we need to do is, it's not dividing by, it's inversing. It's like if you're multiplying, if you, for example, here the 8 was dividing, to get rid of it, we multiplied both sides by 8. So here, to get rid of a sine theta, we're going to inverse sine both sides. So sine -1 of this and sine -1 of that. So we got theta equals sine -1 of all this stuff, 8 sine 40 over 6. So we can do it in pieces if you want to. So I'm going to grab my calculator, and I've got 8 times sine 40 divided by 6. It gives me some horrible looking decimals. So theta equals inverse sine of 0.85705, 0.85705, but I would never put that number back in my calculator. I just keep on using it, right? So I'm going to say second function sine, so inverse sine of whatever that answer was. Okay, most calculators let you do that. And so we get theta equals 58.98, so 59.0 if we wanted to round to 1 decimal place, or if you want to go to 2 decimal places, 58.99. Okay, so, whoops, 58.99 degrees, alright? Seems a bit crazy, so I'm going to go ahead and say theta equals 59 degrees. Big line around it. Now let's go see if it looks reasonable, 59 degrees. So I come back up here, this is 59 degrees, that's what we worked it out as. This was a small angle 40, and it gave a small number 6. This one's a bigger angle 59, and gave a bigger side 8. Seems reasonable, and it's in the right context.